Hi everyone, it's Sorkin. Today we have a problem when we are given an equations. So for example, in this case, we are given a to b, a to c, and b to a. Also, we are given values, which is the value of converting a to b, a to c. For example, in this case, a to b is 2.0, for a to z is 3.0, and the b to d, which is 2.0. Also, we are given a query, so which means that we need to return the result of these queries. So for example, let's say that we need to convert b to a, we need to convert b to a to d, and we need to convert b to x. So what's the result of those conversions? So what's the values of those conversions? So for example, in this case, in the first b to a, right? So a to b is 2.0, which means that the b to a is 1 divided by 2.0, which is 0.5. A to d is 4.0, which is that we are converting a to b, the value of it is 2.0, and the converting b to d, so the value of that is also 2.0, which gives us 4.0. So it's a 4.0, and the b to x is -1, because in this case we don't have x in our equation, so we don't have as an input, so we are returning -1 for it. So what are the steps for solving this problem? The first step is what we are going to do here. We are creating a hash table. So in Java it's a hash map, in the Python it's a dictionary to store our conversions. So for example, let's say that for a, right, a to b we have is 2.0, a to c is 3.0, and also we have b, right? For the b is we can, for the converting b to a, which is that the 1 divided by 2.0, and the b to d is the value of it is 2.0. For the c, we have c to a, right? It's a 1 divided by 3.0, and the d to b is 1 divided by 2. So we are storing these values in our key value storage. So the next one is what we do is we are DFS searching to find our queries. So for example, in our case first, right, let's take the a to b. So let's say that our query of the, let's say, b to a. So b to a, we are searching in our key value, right? For the b, we can convert b to a, and the value is 0.5. So we are setting the value for that 0.5. How about converting a to d? To convert a to d, first conversion of the value of a to b, right? So we are DFS searching a to b, and so then we are searching another neighbor, which is d, and we are multiplying those values, and we are returning that. For example, in case of the a to b to x, we are going to return -1, because we don't have node x in our graph. First thing that we do here, we are creating a graph, a dictionary, where we are storing our equations. So for example, in this case, we are going over our equations, and we are storing in the graph, we are storing a to b, which is our value, and also we are storing b to a, which is 1 divided by the value. After forming our graph, what we do is we are creating an array of result, and we are going over our queries, and we need to find, so we are DFS searching for the, for example, let's say that we need to value of the a to d, right? So a is in this case is a, and the b is d, and also we are passing here a set where we are storing each node, not to revisit that again. So what we do is in our DFS function, so first thing that we are checking that if a is not in our graph, or b is not in our graph, then in that case we are returning -1. So for example, let's say that we have a to x, right, but we don't have node x, and in that case we are returning -1. If the a equals to b, so let's say that our query is convert a to a, right? So in that case we are returning 1, because a to a will be 1. And if it's not, if this base case, if we are passing these two base cases, then in that case what we do is we are adding our current node to the visited, to the set, and we are going over each neighbor of graph, or of our current node. So, and in each case we are checking that if our neighbors in the visited, so which means that we have already visited that, we are skipping it. If not, so we are calling a DFS function for that neighbor to find our result, right, which is in our case, for example, let's say A to D, which is D here, and we are passing our set here. If our result is not equals to -1, then we are returning result multiplied by value. If it is, then we are returning -1. So for example, let's say that in this case we need to find A to D, right? So, and the A has two neighbors. A has A to C. So what we do is we are recursively calling for C, right? C doesn't have any neighbors. So in this case, we are going to return -1 for the C, right? So we are going to return -1, which means that we cannot find in this branch we cannot find our node D. And then the next one, we are recursively calling for the B, because another neighbor of the A is B, so we are calling for the B, and for the B we are recursively calling for the D. And in this case, D doesn't have any neighbors, but the D in this case, right, we are passing a neighbor. D is equals to our result. D is equals to D, which is 1, so we are returning a positive 1 here, so which means that here we are multiplying 1 to 2, because B to D is 2, right, value, and also we are multiplying A to B, which is also 2, and as a result, conversion of the A to D, we are returning here 4. So what's the time and space complexity of this solution? The time complexity is E plus Q multiplied by N. What's the E? So first thing that we do, we have one for loop here, right? So we are going over our equations and we are building our graph. The time complexity for that is the size of our equation, so it's E. And also what we do is, in the worst case scenario, for each query, we are visiting all the nodes. So the time complexity of that, right? Time complexity of going over each node, and for each equation, for each query, we are visiting all nodes in the worst case scenario. So it's a Q multiplied by N. So our final time complexity is E plus Q multiplied by N. So about the space complexity. In space complexity, we have two data structures here. We have E, right? So we are building our graph dictionary. So the size of that would be E. So it's the number of the equations that we have. Also in the worst case scenario, we have the DFS recursive stack, right? In the worst case scenario, the size of that, it will contain all of our nodes. So we are adding that also to our space complexity, and our final space complexity is E plus N. Okay, that's it. I have also Java solution for it. It's identical to the Python solution. I will include that into the description. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.